So, page 7, new book here. Let's find out how accurately we can measure, which is what the lesson is called. How well can we measure? First thing I want us to consider, so the student got 16 out of 21 correct on a quiz. Use mental estimation to answer the following questions. Did the student answer less or more than 60%? And did the student answer less or more than 75? So how can we get that mentally without actually dividing it? Most of the time you got to get to a nice number. Let's say we got to 20. Whether you shoot free throws, shoot clay pigeons, do something 20 times. How many times would you have to be successful, like on a free throw, to get 80%? Or it could be questions on a quiz. Okay, so let me ask you this. Percent is out of 100, right? So 20 times 5 is 100. How many would I have to make out of 100 to get to 80%? 80. So what times 5 is 80? Yes. 16. 16 out of 20 is 80%. So if you're at the free throw line, you make 16 out of 20, you're an 80% free throw shooter. Now, you shoot another one, you miss. Is your percent going to be more than 80 or less than 80? Definitely less than 80%. Okay, now let's compare it to 75. So how many free throws would I have to make out of 20 to get to 75? What's that? 15. Okay, so you make 15 out of 20. You're a 75% free throw shooter. You step to the line and you make the next one. Is it going to be more than 75% or less than 75%? More, because you just made it, right? So that is one way of looking mentally. Is it more than 80, less than 75, and so on. So we know it's between 75 and 80 now. Okay, bottom of the page, 7, it says, here are 9 squares. Your teacher will assign your group again. We're not able to go in groups, so we're going to pick a few of them here, and we are going to put the information in this chart. Okay, so we're going to pick 3. For those of you that have rulers with, pick a square for me. What's that? A. So measure the diagonal. Notice it wants a diagonal and perimeter. Measure the diagonal of A. That'd be across the square. And if you don't have your ruler, that's fine. I'll kind of show you underneath the camera here. And we'll see if we can decide together. It says in centimeters. What do you think? What's that? 3? 3.2. I would say 3.2 is pretty accurate. All right, I'm going to do 3.2. A diagonal square A. Now the perimeter. To get the perimeter, we need every side. So what do you think on one of the side lengths there? 2.2 or 2.3? 2.3, fine. So if every side is 2.3, what is the perimeter? What's 2.3 times 4? Rylan, 2.3 times 4? 9.2, thank you. All right, while we're doing 3 of them here, let's go ahead and put it on our chart. Okay, so our diagonal is 3.2, so a little more than 3, up 9.2, and I'm just going to put an A there for triangle A. Not triangle, rectangle A. All right, pick a different one. H. Okay. Diagonal of H. How far? 7.5? All right, I'm good with that. And side length? 5.2. So 5.2 times 4. 20.8. So let's plot that point. 7.5 would be between 7 and 8. And just shy of 21. And that was square H. All right. One more. Says we were going to do 3 of them. F. All right. Diagonal of F. What do you think? 2? 3? 6.3, all right. 6.3. Perimeter? Well, looks like one side is a... What do you think, 4.4? So 4.4 times 4. 17.6. All right, we're going to add our dot. 6.3, so a little more than 6. Up 17. And that was what, F? All right, so would you say that the diagonal of a square and its perimeter is proportional? Okay, we talked about proportional relationships last unit. Does it go through the origin? Yeah, diagonal of 0 would have a perimeter of 0. Do the dots line up? Are they linear? Yes. So is it proportional? I would say it is. So every square, it would be on that line, no matter what the size of it is. All right, number 3. What do you notice about the points on the graph? Linear? And probably that it goes through the origin or lines up with the origin. Again, that means 0, 0, not some mystical creature carrying Viking Super Bowl rings or whatever the question was. All right, so we are going to use the same squares that we just looked at. So can somebody look back and tell us the diagonals of the ones that we did, please? And we're going to transfer them. 8.2 and what? 3.2. Then what? For what letter?
And then for H is
7.5. All right. All right, now we're going to have to figure out the areas. So the side length was 2.3. Remember to get area, it's length times width. Why don't back table, Kellen, Shark, you three guys, 2.3 times 2.3. F was 17.6 times 17.6. First two rows, Winnie the Pooh table. You guys do that one. And H, 20.8 times 20.8. Middle rows. See what you get, please. Yes. All right. You guys got the first one done? 5.29? Okay. Square F, you guys got that one done? What? No? Well, there's 6 of you. Check it.
I got 309.76.
309?
Well, yeah, if you look at the same number.
Okay. Next one.
We don't know. You all got different
We all
answers.
got, they took, I remember they took.
I don't think you should listen to Maverick's answer. Probably you know.
Well, 20 times 20 is 400.
And Jody, you got 43,000.
43,000.
3,000?
I got four.
Maverick's answer is 5.
I feel like
Yeah.
you're right.
There's a decimal somewhere.
I feel like
It's not like right there.
Maverick's answer is wrong.
I got 432.
432.64.
Or 32 points.
I got. Told you where you was wrong.
All right, so remember area of a square, guys, length times width. I'm going to go up here, just make a quick little sketch. We're going to put diagonal on the bottom, area on the side. 1, 2, 3, 4, 5, 6, 7, 8. Area now. Can I go by ones? No, it's all the way up to 400, you told me, so I almost got to go by like 50s. All right, so I went by 50s, and I marked every 100. So the first square you guys told me diagonal was 3.2. Remember, this is 50, so go up 5 is not going to be very high. 6.3, you told me the area was 309. And 7.5, the area was 432. Proportional? Dots line up. Does it go through the origin? Origin is right here. No, there's no way that that is all going to happen. Okay? You would actually get something that would look like that if you plotted every point. Not proportional. Okay? Not proportional. So what do you notice about the graph? Not proportional. So diagonal and perimeter was, diagonal and area is not. Now why is that? Well, because you're squaring something in area, as we talked about from Unit 1. If you square something, it is not proportional. That's what area is. That's why the label is squared on area. So if you're graphing anything with area, it is never going to be proportional. Question 3. How is the relationship between a diagonal and area the same as the relationship between a diagonal and perimeter? How are they the same? How are they different? Same, different. Same. Diagonal goes up, the perimeter area goes up. Alright, the bigger the diagonal means the bigger the square, means the perimeter area is going to be bigger. How are they different? One is proportional, and one is not. All right, so just know that diagonal and perimeter is proportional, diagonal and area is not. Last question we're going to discuss. Okay, on Monday, the mail route follows the following route. Mail truck, excuse me. A, B, E, F, G, H, A. So it goes right down here. Does the bottom route. It's a total of 14 miles. Tuesday, it does the big route, big rectangle. It's a total of 22 miles. So we have to figure out basically what all the sides have to be in order to equal those. So probably the easiest is the trial and error. Down here it looks like I have a square. So what number do you want to try to go around that square? Give me a number to try. 4? All right, so if that's 4, that's 4, that's 4, that's 4, what do you think these two pieces here would be then? Ones? So does the distance all the way around there equal 14 then? Four, 16, 17, 18. So the 4s are probably too big. So what do you want to try instead of 4?
3.
3? Does that equal 14 around the bottom?
Yes, it does.
3, 6, 9, 12, 13, 14. Yes, it does. Now let's do the top. This rectangle, the big one, has to equal 22. You told me that this was 3. These are all 3. So what do the big ones have to be to give me a total of 22? Well, let's add up what we have. We have 3, 6, 9, 12. We have 12 already, right? So how much is left to get to 22? 10. So they would have to each be 5. Now, to see if we are correct, he does the outside route on Wednesday. See if it equals 24. So going around the whole outside, see if it equals 24. So 1 plus 5 is 6, 7, 8, 9. 9 plus 8, 17. 17 plus 4, 21. 21 plus 3. Does that equal 24? So it looks good. So now I should be able to answer Thursday. Thursday goes B, E, F, G, B. So this little route right here. How many miles is that? 12 miles. Answers that question. All right, couple reminders before we let you work on the homework here. Looking at a graph, again, you can tell if it's proportional, if it's linear, and it goes through the origin. Okay, if you have a chart, how can you tell if it's proportional? Second column divided by the first. If you get the same number, it's proportional. If you ever see a table and you don't want to graph it, take the second number divided by the first. Okay, so it looks like they have weighed a bunch of pennies here. Does every penny weigh the same amount? Well, if you divide it out, is every penny weighing the same amount? No. No, older pennies are actually heavier because they're actually made with copper. And now they make them in lighter metals and cover it with a copper coating so they're the same color. Okay, but not every penny weighs the same amount, not proportional. All right, your homework. Page 13 and on 14, there is just a graph there to help you with question 4. Okay, everything else should be self-explanatory. If it says about, I see a lot of about and approximately and estimate. Okay, just looking for a close answer there. Number 3 does say explain. And don't forget to do that. And you should have plenty of time to get that done. So you do not have homework. So you have the rest of the hour to do that.